Good afternoon, everybody. I'm Dan Schitt. I'm from the Open Networking Foundation. If you haven't heard of us, it's no surprise. We're only 8 months old. And I will tell you why we are here. We're in the guts of the network, but we are here actually to, number one, democratize the network, and number two, make the network disappear. We want to see the network viewed much like the electrical jack on the wall. Nobody in the enterprise has a department of electricity. But right now, they have a lot of people involved in networking, and as, who was it? As Alan Cohen said, 70% of the enterprise IT cost goes into maintenance. Well, we think that includes also such things as configuration and operation. And our goal is to make a lot of that go away. So we're helping to virtualize the network so that it serves the needs of applications and users and really the computing strategy of the enterprise. It also applies as a very broad technology, what we're doing, to service providers, and will apply to things like home networks that barely even exist today. So the Open Networking Foundation creates open interfaces to the network. And in particular, we are standardizing something called OpenFlow, and I'll show what that is. That's not that important for you in this audience, but the impact on the applications and the services in the enterprise network are what is important. So you'll see here that on the left side it's really why we exist, and on the right is sort of who we are. And I think you're more interested in why we exist, which is that people who run networks and they use networks for services, whether enterprise or service provider, are finding that the network is a problem and the network is a bottleneck. The networks are scaling the way the computing infrastructure is, but with great pain. We've seen how the servers and the computing parts are scaling in places like Amazon Web Services, in Zynga, in Yahoo and Microsoft and Facebook, and of course Google. But with great difficulty. The network does not scale in terms of ease of use the way the servers do. It has not been virtualized, and it's really a problem for the enterprise IT manager. So we're helping those managers find ways of actually programming the network. And so we're standardizing some interfaces and some concepts and constructs that allow you to do that. The networking part is, we've all been in networking throughout our careers here up on the stage, and it's been a lot of fun, but it's also been a lot of frustration. Networking is a trade. It's not really a science. We want to make it more of a science. We want to include some fundamental abstractions in how it works, the way distributed computing has evolved in the last 30 years, and networking has not. And finally, we think that the IT manager, who's in charge of where the applications are, how the servers run, and the services are provided to users, will also be in charge of the network. And there really won't be a big network guru because the network won't be that important. It won't be a factor anymore. It will be there to do what everybody needs it to do. We are an organization. We're a 501c6 nonprofit. We're 8 months old. But we do create some standards. We're promoting this concept of software-defined networking, where you can write your own software to determine what it does. We are a standards organization that is very different from most because we are driven by users and not by vendors. We have a lot of vendors participating, but they don't call the shots. And we're trying to iterate very quickly, and we're trying to absorb sort of the culture of the computing world, and I'll talk about that in one of my slides. So the Open Networking Foundation is headquartered in Palo Alto, and we're making software-defined networking the way we always should have done networking, but haven't done so right now. Our real goal is to change the whole landscape of the marketplace, so that you'll find services and products that enable software-defined networking and put the applications in charge. This is a combination of kind of a network diagram and a software architecture. Very simply, what we're standardizing is a little thing down there in the middle called OpenFlow. And OpenFlow is very simply a way of taking a software program running in a server that we call the network operating system, and having it program the packet forwarding devices and just tell them what to do. It's as simple as that. But basically, if you look at the history the computing devices have been very distributed, they've been horizontally layered, we have different operating systems, different applications, lots of people contributing. The networking industry is still living in the world of mainframes. You buy a big box from some vendor, I won't name any names here, and they have their own proprietary silicon, their own operating system, all the features they have to do, and it's a complex box that you cannot program. Moreover, they're autonomous, they talk to each other through these complex internet protocols, and it takes forever to get anything done and to make some changes. We're devolving those into simple packet forwarding devices using merchant chips and what we call cheap Taiwanese switches. And all they do is accept commands. The intelligence in the network goes from the boxes themselves into the software hierarchy above the network. I've shown a lot of pieces of this. It doesn't mean that this is actually how it's done, simply that these are the things you can think about. I've got the words apps up there, and those applications can be a variety of things. Sometimes we think of them as a network-based application, such as admission control. Who gets to use the network? You've got people coming in with their user-owned devices, whether it's the tablets or the smartphones or something else, and it'll be something else in a few years. How do you guarantee that you can secure the data you have in your network with these foreigners coming in? It's much easier to do this because you can do it yourself with a few lines of code. The control programs are how the network operates. It could be traffic engineering, it could be policy, it could be conformance and compliance with some kind of regulatory statute. It can be any number of things. The point is that you can do it yourself with simple programs that run in commodity servers. One of the comments from the earlier panel was how we're going to have software people in the enterprises who aren't really running networks. They're doing useful things like programming things for the unique uses of that enterprise. We think there's going to be a growth in that sort of software developer in the enterprise as well as in the service provider space. And of course the big green of virtualization. Yes, the network will finally become virtualized like the server infrastructure has been for the last few years. You want to move resources around. Somebody takes care of the plumbing, but nobody really cares about the plumbing, who's high up in the company decision-making structure. This timeline just shows a little bit about us. It's not that interesting to you. We came out of some research at Stanford. So this protocol called OpenFlow, which is really just an essential component for enabling all the software richness, it was a Stanford PhD dissertation. It became of interest to a lot of industrial partners, and so they published a few versions, culminating in version 1.0 and then version 1.1 in just February last year. We were chartered and launched publicly in March of last year. We just issued OpenFlow version 1.2. It adds things like IPv6 for the world market and so on and so forth. We are a member-funded organization. We started with 23, we now have 51, and we're a very active and viable organization with representatives from all over the world. Some of them are on the panel today. This we call the Open Networking Foundation ecosystem. These are the kinds of companies that are in the Open Networking Foundation. You see around the perimeter here, we have hardware and software companies, virtualization companies, chip companies, what we call controllers. I'll let some people talk about that. Management companies, application companies, and you can think of this again as both sort of network guts applications and network virtualization applications and network use applications. And then system testing, training, we have committees on that and companies that do that sort of thing. In the middle are the users. And what's interesting about the users is that they're in charge. So we have service providers, we have Facebook, Google, Microsoft, Yahoo. These are companies that are actually on the board. So I'm going to introduce the panelists and to show where they fit in here. And by the way, Alan Cohen earlier wouldn't say where Nicira lives and what it's really doing. They're in this chart somewhere, but I'm not allowed to tell you where. So we have around the outside, we have Rakesh Saha on my left from IBM. You can see they play in a number of these sectors. And I asked Rakesh in October how important networking was to IBM's computing strategy. I started my career at IBM, and networking was really important, and then IBM got out of networking. Well, now they're back in. I asked him how important it was. He said, I cannot overestimate to you the importance of computing, of networking in IBM's computing strategy. You see they play here several places. On my immediate left is Isabel Geese from Big Switch Networks, and you see there in the management and applications areas, and also the controllers, and she'll tell you more about what they do. And then in the center is Amit Agarwal. He is with Google. Google is on the board of ONF, along with Yahoo, Facebook, Microsoft, Verizon, Deutsche Telekom, and NTT Communications. And he'll tell you a little bit about what Google's slant on this all is. So I'm going to turn it over to the panelists now. I've asked each of them to think about a couple of things. Why are their companies involved in this movement for the democratization of networks? What is the value what is the opportunity for their company, and what is the value to their customers, especially to the enterprise user that they are trying to sell to, or that the service providers are trying to sell to? So let me start with Rakesh on the left. Why are you here? Why is IBM here? What is the opportunity for you? What is the value to your customers?
So, thank you, Dan. The big thing about IBM is that, as you can imagine, IBM has its hands in almost all the aspects of communication, and IBM believes in open, standard-based solutions for our customers. So, if you look at software-defined networking and open flow, this is for the first time that you have a way to actually go and do something in your network in an open and standard way. And that brings up very interesting scenarios for our customers. So when we go and talk to our customers today, many of them are very large customers. They have large infrastructure that they spend a lot of money on, and they would like to use it as efficiently as they can. What happens today is that they are able to use their servers quite efficiently thanks to several virtualization technologies, but they tend to hit a bottleneck when it comes to other parts of infrastructure, especially in networking. And in that space, they are limited by the reasons that Dan just pointed out. So we see a lot of great potential in this new and upcoming technology, which will let us build solutions for our customers, which will be more efficient and more tailored to their business needs. IBM is into big data analytics and all kinds of compute that you can imagine. And having this level of control and programmability of network allows us to clearly build solutions for our customers that is really suited to their needs and applications.
Thank you, Rakesh. Isabel, you're also for a vendor company. What is the opportunity for you and the value for your customers?
Well, our customer, and you saw it throughout the day actually, are deploying applications, are using more and more servers, our users are more demanding, you have more devices. The traffic patterns has completely changed. You have more sophisticated applications that need to talk to each other, but the underlying network has been innovating at a very different pace. And most of the time, the reason why customers come to us, or a company like IBM, is because they realize they have a moment where suddenly they want to roll out application and they cannot. It takes a few seconds to configure the server and the computing side, and then it takes weeks to configure the networks. And when it's within an enterprise, it's a lot of complaints from different business units, as we mentioned this morning several times. When it's a public cloud company, it's a competitive disadvantage because you're pretty much pay-as-you-go network services and application company. So for us, the reason why Big Switch was created last year, we were a startup, still in stealth mode, and we were founded in March 2010, was really with the open standard, open flow, and the entire concept of software-defined networking. We could bring the flexibility, the dynamic change to adapt to business needs, and the programmability that we have on the compute side back to the network to realign the compute and the networking pace. And with this new technology, there is also value to deliver new services, new applications. When was the last time your application asked, do you have enough bandwidth to do video actually? Right now, for instance, we select, I want this definition, I'm on my computer, I want a 1080p video, but maybe the network's not ready. And maybe, if we could tell you right away, no, you may want a lower definition to have a better experience actually. That's something that doesn't exist. It's two separate worlds evolving at a very different pace, and we're trying to catch up, and that's what Big Switch Networks is working on.
Let me just point out that with the current internet protocols, of which there are about 6,000, for the reason the routers are so expensive, there is no way to send different kinds of traffic between the same two endpoints over different paths in the network. So you might have a low latency kind of traffic like interactive, or a high bandwidth kind of traffic like a video feed. There is no way to route those separately through the network in the traditional way. With OpenFlow and software-defined networking, you can take each of those and do exactly as you wish, controlling them however you want, maybe allowing some and simply not allowing others. You can even say, from this kind of a device, I will allow it, and this kind of a device, I will not. So an unprecedented level of control for the architects of the IT infrastructure. Let me turn now to Amit. You're a user of this. You build networks. You have a big enterprise company yourself. What is your interest?
Thank you, Dan. So I think throughout the course of the day, we have talked about big data, about Evernote, and all these different apps and services. So I think, let me just give you some flavor of what we are talking about, right? Today, I think more than 1 million smartphone devices come up online today. People are uploading upwards of few hundred millions of photos every single day. Tens of thousands of hours of video is being uploaded every single day. So what does all of this entail in terms of requirements for the underlying infrastructure? And this is not requirement just from a networking perspective. It touches upon servers, it touches upon storage, it also touches upon networking. Right? From a networking perspective, I think a few things that you really want is something very fast. And fast because you want something really fast and responsive. You go to Google and you type in search, you want it to be really instant. You want to get the answers in hundreds of milliseconds, or even faster, not seconds. You have all this data around, you want to move it around. You don't want it to take days, you probably want it hours or even minutes. So you require fast networks. The other thing is around security. How secure are your devices? They are as secure as the network that is transporting the data that is transported by the network. So you also want the network to be secure. What OpenFlow and SDN does is it decouples the control plane from the forwarding plane. So you literally have an operating system in which you can build apps. You could call it the network OS, you call it the mobile OS, very, very similar to what we see in the mobile world. And you could build different applications that serve very different needs. Just like you probably won't have Evernote there, but you could have something equivalent that offers you security that says, hey, I'm only going to allow devices X, Y, Z to enter my network, or these devices to access maybe only these 3 sites. So that kind of richness is allowed by this decoupling of the control plane and the forwarding plane. The other thing that we have seen is in the last decade or so, there's been a lot of advances in terms of large-scale distributed systems. And today we don't worry about Gmail or any other mail service provider. We just take our mail, move around, go down the world, access the service, it just works, right? In the last 15 years, things like GFS, databases like Bigtable have become very, very commonplace. By this decoupling, we can have innovation in parallel, both on the controller side and also on the forwarding plane side, and pretty much leverage all the work that has already been done. So I think SDN and OpenFlow will help us evolve and improve the networks today quickly compared to what we have today, and that's where we see a lot of value in it.
Now, if you think about how this actually rolls out and who makes the buying decisions and why they're buying, let's look at the enterprise buy side. Who is making the decisions about this now? To whom are you appealing? I'm going to ask Rakesh this first and Isabel second. To whom are you making this pitch in the enterprise, and how are you seeing them start to absorb these concepts into their computing strategy? Rakesh.
Thank you, Dan. So we actually are going and talking to customers about this new exciting technology at multiple levels. But at a very high level, we are going and talking to all the CIOs and people who are in charge of the entire infrastructure, not servers and not networks and not storage, because that has a silo mentality. What we're trying to show is that with software-defined networking, you now have a global view of the entire infrastructure, right? And then you are able to optimize and make efficient use of your entire infrastructure that is available to you at an enterprise level. So think of the CapEx and OpEx savings that you can do if you were able to do things at the global level. This is very similar to sort of what happened in the server virtualization world. Before virtualization came along, there were physical servers that were bought for different customers, different departments. They were siloed because the capacity for those load demands were calculated, and then servers were bought for them. Now what happened with virtualization was that you were able to now run virtual machines which were hosting your application from different departments or different customers on the same physical hardware, and the usage shot up from this historical low of about 30% to about 80% in the server world. Now if you look at the same thing on the network world, we want to do the same thing, and by having this software-defined network which gives you a great global view of the network, you can do that. So that's one level we go at. The other is that we actually also go and talk to the teams who actually go and are practitioners of this art today. And we tell them, see, the way you do it today is very complex. I mean, your whole life is revolving around babysitting the network. And you get a call at 2 a.m. in the morning that the network is down and bandwidth is not enough for my application, and so on and so forth. So we are trying to show them that using software-defined network and the fact that it has a feedback loop to your application ecosystem, you can have a more deterministic network, and you'll be able to design and implement a network that better meets your needs and doesn't have to be very fragile as it becomes today at a very large scale.
And Isabel, when you talk to your customers, whether they're enterprises or service providers, what are they thinking about their mobility strategy when they think about SDN?
Well, to be honest, this is a network that's supporting any type of device. Mobile is becoming more and more predominant, as we discussed today, but also fixed one. When we came in with a customer, there is a lot of pressure on the network manager from many sides. First, the user side, because they want to have applications that are more that will have requirements on the network that need to be implemented and cannot be implemented fast enough. The server administrators, because the applications are running on their compute resources, and those resources are not utilized because the network cannot accommodate them. Even the network manager, we want to introduce different vendors. Some of them having a different, being more performing in data center and other in campus. However, right now there is no way to have a single way to use this throughout the network. And back to your question, if I'm a mobile user on campus and suddenly I go to my headquarters, I want the same experience, even if the network underlying it is different. And finally, we have the security team who wants to introduce new devices and doesn't feel they have enough visibility end-to-end to secure the whole application and allows for mobility. It could be mobile devices, but it could be also a user being mobile from one side to another, having different access rights. So clearly there is a lack of visibility end-to-end and tools for network manager to accommodate all those constituencies and have freedom of choice on the technology they want to implement and the timeline they have to implement it.
Thank you. And my last question will be directed to Amit. Google's known for building a lot of its own stuff. Do you view this concept and the instantiations of it as more as cost savings or as flexibility or as adding new features? How do you weigh those different potential values of this concept?
So I think when you look at it in total, I think it is not just cost saving. Cost is definitely a factor there. But I think there was a study done in a university where they were trying to see the TerraSort is an application where basically trying to sort terabyte, a trillion numbers or so, and then you see how fast you can do. And they actually showed in that study that if you use a faster networking interconnect, you could basically leverage more of your existing storage and CPU resources. So it's definitely not a cost saving. You got to look at this in totality, like how much money am I spending in networking and how much benefit am I getting. And I think Isabel, you mentioned about features where, and Rakesh, you also mentioned about applications where you close the feedback loop to tell applications that, hey, you can't be running on this because either the network is of low quality or the bandwidth is not enough. I think those services are very, very valuable, not just to run the service effectively, but also to the end user so that they know what is going to really happen. So I don't think it's a cost saving game here. I think it's more about investing more in networking. I think networking has been, people have underinvested in networking compared to storage and CPUs, and I think ST allows you to better use the network and invest more in the network.
Now, when I tell friends, relatives what I'm doing about this, who are not in the industry, they struggle to understand how it relates to them, and I struggle to explain how it relates to them. I think that's a sign that it should really be invisible to the user and to the application user. But I think it should foster ease of use in applications, lower cost services, and more applications that are available to the end user. So it'll be an indirect benefit that I think many people will see. And if we're really successful, we will truly be invisible. And that's where I hope the network goes to. So we have time for some questions.
We have time for one question. We have a question from the audience for this session here. You've answered every question about open networking. Anybody? We have a question.
Sure, my name is Molly Stein. My question is, how do you think this technology will help accelerate adoption of cloud in the enterprise?
So, Amit, you guys are going you run a cloud, so what do you think?
So I think like when you look at the user experience side, right, that's very, very important to Google. We want things to be very fast, the services to be very snappy and very interactive. So if we can build the infrastructure is really good in terms of giving that kind of qualities, the users will benefit. Right? Today, like you can't really think of downloading a 1080p video. Right? It takes quite a bit of time, no matter how fast a connection you have at home, because of various bottlenecks. What if you could download a 1080p video at real time and not have to wait even 5 seconds, not have jitters when you're downloading video at all? Those kind of things I think will help adoption a lot more, and people will be less reluctant to move things to the cloud because they get the same kind of service that they would get if the data or the service was running locally.
Go ahead, Isabel.
I would add that, we talk to a lot of public cloud providers, and for them, there are more and more of them offering services. For them, it's a key differentiator to be able to roll out a service first, or to have a granularity level that's enough for their user to configure themselves, delegating, and back to Amit's point, to have the best experience. For them, it is a question of being and staying competitive. The technology is evolving so fast on the application side. If they don't have the network that back it up, suddenly their core business is at risk. So in terms of cloud, and especially public cloud, right now where you have a lot of innovation and new companies, I think most of them are coming to OpenFlow, and large companies and enterprises are looking at integrating OpenFlow progressively. Public cloud, they want OpenFlow everywhere because it is core to their business.
I can give you a couple of commercial examples. Microsoft is very active in the Open Networking Foundation and on the board, and OpenFlow and SDN are really essential components of the Microsoft Windows Azure Cloud Windows Service. Also, a number of the service providers that we talk to are adopting it so that they can, in fact, offer cloud and data center services to their enterprise customers and compete with the independents who are offering data center and cloud services.